this lesson, we are going to create the retractable quad blade automation and also add RPMs to the rotors. Right, so to follow along, you can open c_07_roborigging_start.blend so you can follow along. So this is basically the file from the previous lesson. All right, so we need to have the timeline because we're going to create a tidbit of animation. And don't worry, that's not going to be a very complicated animation. And we also need to pop another window because we need the dope sheet for the action editor. All right, so if you click here in the dope sheet, we can have access to the action editor. Right, so what we need to do to automate the quad blade opening is to create an animation of that and then save that as an action. And then we can remove the action from the timeline and apply that as a constraint, right? So there's an action constraint where you can actually create an animation from it. And from there, you use another object to actually control that. So first, we need to create the animation by using the keyframes on the timeline. One thing to do before starting to set some keyframe and using the auto keyframe, we need to go under Edit and under the Preferences. If you go inside the Animation tab of the Blender Preferences, it's best if you have only Insert Needed checked as well as only Insert Available. So if you put the automatic keyframing on, it's not gonna just key everything like it does if you don't have these two options on. All right, so simply close that. And now we need to add a action. So we're gonna create a new action and we're gonna call it quad or quad blade or whatever. It doesn't matter how we call it. So quad, as long as we know which animation we have to get. So that's for the quad blade. So we need to set a few initial keyframes. So this one only moves in the y-axis, so right click and set a single keyframe. Then we're going to select the other one. We only want to key this one as well in the location. So we're going to insert a single keyframe there. And then for each of these retractable blade, we need to key both of these values. So insert single keyframe, insert single keyframe, and we're going to do the same thing. So key the unlocked values on all of them. All right. I'm going to put the object selection off so I don't accidentally select it. All right, and let's do the same thing with the one at the back there. All right, so now we've got these initial keyframes. So if we put automatic keyframe on, which is this little button here, whenever we move to the timeline and do something like grabbing this and moving it up, for example, it will actually take it into consideration and add the keyframe automatically, as you can see. Now from here, we can grab this one and get that one to start from here. So as you can see, I just selected it here by clicking on it. And I know it's this bone because if you select that bone, it highlights. All right, so this one, if you select it and press G to grab, you can, move it on the timeline. And we can also do the same for these four because we want to be able to open it from here. All right, so I'm going to grab this. And I will open it and I will grab this, and actually I don't want to open it from here. I want it to start opening from there. So I'm going to go to 40, for example, and then from there I'm actually going to open it. I will do the same thing for the other one. We're going to make them better in a bit. Right, so this one goes to the other side and this one to that side. Right, and this is supposed to move up. All right, so at this point, this should already be up there. All right, so let's actually be precise now. So if I dog this there, this should be a little bit more here. And this a little bit more like that, maybe. And it's important sometimes to be a bit precise. All right. And I think this works. All right. So we've got this animation. So it's a very simple animation, as you can see. So if you play the animation, it does this. And then from there, I want this or this to move down again. All right, so it goes like this. And then I want this one to move down there. So it does this. All right, so this is the opening animation. It's 40 frames long. And it's called quad. So very simple animation. It sort of goes through here So what do we do here? We probably can just grab that and make it move after. So that would be the shaft. All right, so if I do this, now this should not move right away. So let's wait a little bit till it opens and perhaps delay the opening a little bit. So let's just grab these four and move the opening out a little bit. No. All right, so what we're going to do is we're going to grab the rotor movement and we're going to toss it. So now it opens there and then it starts moving down and that sort of fixes it. Now this doesn't open fast enough, so maybe, or a frame right after. So it's experimenting with it. Yeah, that looks fine. All right, so we've got the retractable opening and it's 44 frame. Let's make this a round number. So if you select everything and go to frame 1, you can scale it. All right, so I'm gonna make that an 100 frame. Yeah, that looks fine in terms of animation. Let's grab this and perhaps put it more there. There you go. All right, so we've got our animation. So now what we do is we click on that little shield. Now what this does is it saves the data block even if the data block does not have a user. All right, so now I can do this. Now, don't worry, it's still there. So now I can duck this down because I no longer need it. We're gonna keep the timeline there. All right, so now if I play the timeline, you see it doesn't play anything. So we're gonna take off the automatic keyframe. So now we need an extra bone in there. We're going to go to the side here. We're going to tab into edit mode and we're going to add an extra bone. So I'm going to grab the shaft and I'm going to duplicate the shaft. So Shift D and then Z to move it up. I'm going to bring it on top here and I'm just going to scale it down. Now I do have already a custom bone shape on there. So that's cool. So maybe bring it down a little. All right. It's easy to select. So now what I want to do is I want to use that Y value to drive the action constraint. So if I select this and go here and add an action constraint, from there I can target the armature, can specify the animation. You can see it's here. Now we need to specify the start frame and the end frame. Right? And min and max is the distance the bone needs to travel in its Y location in local space. So we're going to say 0.5 to give it a test. And then let's select the bone. So the bone is going to be this one. So we're going to rename this one quad_C for control. All right. So here, let's grab this and go set this quad C. All right. And now what we can do is to select the other bones and then shift select that one and go to pose and constraint, copy constraint to selected bone. So now all of them have that constraint on. So now if I grab this and move it up, here's the animation, right? Boom. So we've automated that by using an action and then using another bone to actually control it. Now from there, it's just a matter of adding an RPM value to control the spin here, as well as one for this one to control this rotation here. To do that, with the rotor selected, go to the bone panel and add a custom property. We're going to edit it and call it RPM. And since we want integers for this, we're going to enter 0. Let's set the maximum to 250 and the minimum to -250. We're going to press OK. And then we're going to right click and add a driver. So this is going to be a complex scripted expression that use self. All right. So we want this variable to be named FPS for frames per second, and it needs to be a single property that is taking a look at the scene, which is the current scene, and we want the data path to be render dot, not comma, dot FPS. Right? And the expression itself is pi time. Don't forget to make sure it's time. And then frame, and then time again, and then self with open square bracket, and then quotation mark, and then RPM in capital, so it matched the actual custom property, close quotation mark, close square bracket, and I didn't use the square bracket, so there's the square bracket. And then I divide that by open round bracket 30 times FPS, which is the variable here, and we need to close the bracket. So I put 9 here instead of properly putting a bracket. And so you got to make sure that it's well typed. So pi times frame times self, open square bracket, open quotation mark, RPM in caps, because we've put the value here in caps, close quotation marks, close square bracket, times open round bracket, 30 times FPS, which is this variable here, closed round bracket, and hit update dependency. And you'll notice right away that it says 24 here. Why? Because it knows that the scenes frame per second is 24. If I switch it here to 30 and right click here, go to edit the driver, now it knows it's 30. Okay? Now if I switch it to 60, it's going to be the same thing. It'll know exactly what is the frame rate and apply the right speed for the RPM. All right, so revolutions per minute. All right, so let's switch that back to 24 frames per second and let's give it a test. So if you put the timeline on and pop that on, it spins one side or the other, all right, and it's pretty fast. And then you get that wagon wheel effect as well, all right? So after a while, it looks like it's spinning reverse, which is awesome, all right? So now to apply that to the quad rotor, we need that same thing to happen here on this bone. All right, so for that, let's simply copy the driver. So copy driver, let's come here and let's add a RPM property. So RPM, and let's set that to an integer, so 0 and 0. And I'll put only a positive value of 500 on this one, and then paste the driver there. And now if I put that on, well, and press play, you'll notice that it actually works. All right, but I do not want this one to actually control it. I want this bone to control that instead. So what we can do is simply add another RPM value and set that to the same value, so 0 and 0, and a max positive of 500. And then from there, copy the data path and then just drive this one. So add driver plus 0, single property, armature, and then paste the data path, Control V. The dependency. So now if I drive this value, it drives the other one. Basically, in the driver, we use self, and have self checked on means you're referencing to a property on the bone itself where the driver itself also resides, and therefore that expression wouldn't work from another bone. So the solution here was simply to drive the driver with another driver. All right, so basically it's a driver over a driver. And now all we need is some sort of limits for this so it doesn't move past a certain point. All right, so to do that, you simply add a location limit, so limit location, and then we know it's the y that we want to limit in the local space. And I remember from the action constraint that I set the maximum to 0.5, so we're going to set the maximum to 0.5 here so it doesn't move past that point. All right, so now we've got a proper retractable blade that has a RPM control, so it goes the proper speed when we set the RPM, and it even has the wagon wheel effect if you go past a certain speed. All right, so 250 would probably be the fastest that you would want for this, so you can easily go and edit that to have a maximum of 250 or something like that. It's really up to you. All right, so that's how you do a automation of a blade, a quad blade, while it still can be animated at the same time. All right, so a lot of fun, really.